a number as a result of a measurement or a computation. Therefore, we need to well understand the definitions of fundamental terms such as accuracy, sensitivity, precision, resolution, which are very often misused or confused. And the results are not meaningful without giving the error and uncertainty limits with a stated confidence boundaries. In universities, we teach students deterministic, stationary, linear, and homogeneous systems, but the real-life problems are not deterministic, are not stationary, are nonlinear, and very often inhomogeneous or non-homogeneous. So if you give a number, you should try this one with some kind of confidence limit. The measured or computed value is, for example, x plus and minus delta x, which means all I can say is x is between this minimum value and maximum value. So without stating the boundaries of the uncertainties, the results are meaningless in engineering. Remember, physics is a subset of mathematical work, which is another subset of discrete work. So your mathematical solution may not be the physical solution you're looking for, or a discrete solution may not be your mathematical solution. So it is your task to seek the physical solution in the discrete environment. In electromagnetic engineering, the role of electromagnetic fields in our lives has been increasing. We have been surrounded by electromagnetic waves everywhere. We have systems in communication, remote sensing, integrated command control surveillance systems, intelligent transportation system, medicine, environment, education, defense, which are only a few areas where electromagnetic fields have critical importance. We have systems with frequencies from DC to terahertz and with sizes from a few nanometers, small scale, to kilometers wide, large scale systems. And almost all of these systems today are broadband and digital, and they have to operate in close proximity to each other. Then we have to have severe electromagnetic interference problems. So that's why we have witnessed the transformation from engineering electromagnetics to electromagnetic engineering for the last 2 decades. So these are a few engineering titles: microwaves, radar, EMC, biomedical, propagation, antenna, communication. Instead of naming all these, we prefer to call it electromagnetic engineering. And these are a few disciplines under electromagnetic engineering. We have radio wave propagation problems, radar technology, scattering and diffraction theory, antenna design and analysis, EMC/EMI problems, multi-sensor integrated systems, subsurface tomography, remote sensing, and signal processing and imaging. Electromagnetic theory is well established by Maxwell's equation. Here you see the Maxwell's equation in differential form and in integral form. And we also use circuit theory, which can be assumed as a subset of electromagnetic theory, Maxwell's equations. So we start with Maxwell's equations, which is your generic solution, general solution. Once you state your boundary conditions, then it is your problem. So Maxwell's equations plus boundary conditions well-defined problems in electromagnetic engineering. We have analytical exact solutions, either in integral forms or series summation, but only a limited number of problems. Highly idealized problems have analytical mathematical exact solutions. So we usually use analytical approximate solutions, which we call it high-frequency asymptotics. Then, in the last couple of decades, we have powerful numerical packages solutions. And discretization, computation time, and memory are critical in numerical solutions. Usually, electromagnetic problems can be divided into 3: antenna and radiation problems, RCS and scattering problems, and guided ray propagation problems. In all these, we start with Maxwell's equations and boundary conditions. But in antenna and radiation problems, we define and use auxiliary scalar and vector potential functions, and then there are electric and magnetic fields. In some problems, we present total fields in terms of incident and scattered fields, and since we know the instant signal, instant field, we focus on scattered fields. For the guided wave propagation problems, we apply transverse and longitudinal decomposition and deal with eigenvalue and Green's function problems. These are the discrete observables. We have rays, we have modes, we have beams. We can use them in a hybrid form, and lately we have time domain objects. Observable means computable and or measurable. So in summary, we have high frequency asymptotics, which are grouped into two ray-based models such as geometric optics and GTD, UTD, and current-based models such as PO, physical optics, and PTD. And a few well-known numerical techniques are also given on this slide: FDDT, PLM, which are time domain methods, method of moments, parabolic equation, and finite element, physically frequency domain problems. Now, when you face an electromagnetic engineering problem, you should consider the frequency, signal strength, time duration, discontinuities, impedance, and your geometry. And please take into account these relations: time-frequency relations in terms of Fourier transform, frequency geometry relations, and frequency impedance relations. Now, let me move on electromagnetic modeling and simulation and some definitions. Now, we deal mostly with deterministic problems. We search roots, we solve systems of equations, we do integration, we do differentiation, and we interpolate and extrapolate. But life is stochastic, so randomness, probabilistic, statistics, error uncertainty, and confidence limits are also critical. In electromagnetic modeling and simulation, we mean physics-based simulation. We're not talking about past train simulation or virtual reality simulation or mannequin-based simulations. And the physics-based simulation means computer numerical simulations based on physical understanding and conceptual or mathematical representation of a real-life problem, device, and system. And here are the definitions of a model, simulation, and a simulator. So a model is a physical or mathematical abstraction of a real-world process, device, or concept. Simulation concerns with modeling of real-world problems, and a simulator is a program or a series of programs. Why and when do we need simulations? Very often, it is expensive and time-consuming to do tests with real systems. Sometimes it is dangerous, sometimes it's impossible because we don't have the real system yet. And very often, we want to play what-if type games with simulations. So this is a generic structure of a modeling and simulation. We have a real-world problem. We use a conceptual mathematical model, and then we write a computer program. We do numerical analysis and optimization, and then we use graphics, visualization capabilities, and we design graphical user interface for that simulator. And we call it this in electromagnetics, in electromagnetic package or electromagnetic virtual tool. So we start Maxwell's equation, we do discretization, and we obtain our electromagnetic package or virtual tool. And most of the numerical models are either in closed form, matrix representations, or in open form, iterative representations. Closed form solutions, such as method of moments, are stable, but they need huge matrices, and construction may be a problem. Open form solutions are conditionally stable, small size, and easy to construct. When you build a model, remember you introduce assumptions, you neglect several effects, you do approximations and simplifications. And if you solve your problem with the computer, you do discretization. So the first four of them are, they belong to analog world, but the last one is a synthetic world. So it's a real challenge in the synthetic world to get your real solution. And if you deal with modeling and simulation, validation, verification, calibration are critical. So in VV and C, validation means whether you built the right model. Verification deals whether the model you built is right, and calibration is nothing but testing the result against a reference data. But what is the reference? So that's a critical question. So in terms of terms and concepts, this slide shows you interrelations. We have a real-world problem, physics, a conceptual model, mathematics, and the computer model code. So between real-world and conceptual world, you do conceptual validity. Between mathematical model and computer, you do code verification. Then once you get the results from your computer, you do or you apply operational validity by measurements. So very often we say that we use analytical model or numerical model. This slide explains what analytical and numerical models mean. So in analytical model, you use geometry of your problem, the boundary condition with the analytical model, and then you report to computer and you supply your user data and get the numerical result. But a numerical model-based approach, without computation, you get the results. So in analytical model, actually you solve your problem, computer only gives you the result. But in numerical model, you discretize your problem, computer solves it for you. For example, we have introduced several virtual tools. One of them is shown in this slide as an example one. It gives you radiation patterns of antenna arrays. So this is a simple teaching virtual tool. It's a computer package, but the only equation behind this package is shown on this slide, one equation. So actually you solve the problem. The computer only gives you results in terms of visualization. So this is an analytical model-based approach. But in this one, for example, if you have a transmitter and receiver somewhere at point A or at point U, you can apply geometric optics and GTD, and you may call it eigenray search. You need to define each possible rays, direct ray, 1, reflections, 2, and diffractions, 3. And change the point of the receiver and without direct ray. So this is a numerical approach. And this is another approach, ray shooting, which you apply Snell's law. So this is where you can observe ray paths for a given refractivity patterns. If the inhomogeneous media changes bilinearly, then the rays are bent as shown on this slide. So if you change the location of the transmitter and the inhomogeneous parameters, then you get this picture. Another one here. So you can visualize ray paths through the inhomogeneous atmosphere for given conditions. So another example is shown here. So this is a numerical-based approach, although there is one simple equation also. Most of you may know that we have split-step Fourier-based propagation problems, vertical transverse domain and horizontal domain. So this is a two-dimensional propagation problem. And a four-step solution can be obtained here. I did something. Yeah. So this is a scenario where you can apply a parabolic equation, and as you see, a tilted beam can propagate as shown in this slide for a given conditions. We can do tests if we have reference solutions. One reference solution can be obtained for the linear refractivity profile through the atmosphere in terms of airy functions, and these are the mode functions. And for the antenna tilt angle, number of required modes are shown in this slide. And numerical computation of an exact reference solution may really be a challenge. So although you may have a reference solution, its numerical computation may be a challenge. So here you see the computation of 2D propagation, a top analytical solution and numerical solution in the bottom. And you have two transmitters tilted up and tilted down, and you see the interference. And these are two-dimensional comparisons with analytical and numerical methods. So we include all of them in our recent book published by the IEEE Press. Now, we can use and combine them in teaching and training, and I'm going to show you a few slides about electromagnetic fields. I'm the writer of the testing ourselves column in the IEEE Antennas and Propagation magazine since 2007, and we have published dozens of tutorials there, and we have designed and shared many virtual tools. These are the basics of virtual tools. They need to be simple. The user should be able to change parameters. Some parameters should be fixed so that the user will not be lost, but some are left to the user. This is a ray shooting package. I showed you an example. This is a ray propagation package. This is a scattering package, RCS prediction package. This is a diffraction package. So you can download the tutorial, read them, and then use these virtual tools, mostly MATLAB-based tools, and reproduce the examples given in the tutorials, and then use your own problems. And now the conclusions. Wave-oriented electromagnetic engineering is an effective way of identifying both technical and educational challenges in a rapidly changing internet-driven globalized world. So computer capabilities has revolutionized the analysis of complex systems. Therefore, modeling and simulation and validation, verification, and calibration have become crucial. Engineers need to well understand physics behind mathematics before using simulations and compare numerical results with experimentations. Always keep in mind the assumptions and validity ranges. You need to look at the object as a whole, but also pay attention to every detail in terms of different electromagnetic phenomena. And multiphysics have become impressive for the last decade. Although new approaches such as virtual reality or artificial intelligence are very attractive, hands-on training is a must in electromagnetic engineering education. So basic lectures such as measurement techniques should be renewed accordingly. Teaching training with these tools is highly effective. Students first play with these tools, visualize electromagnetic wave object interaction, reproduce the results of the given scenarios, and then create their own scenarios. They then start electromagnetic theory and play with Maxwell equations. So this will establish understanding physics-math relations. This is the motto I use in my second book, Yes You Can. This is the IEEE motto. Tell me, I'll forget. Show me, I'll remember. Involve me, I'll understand. And this is the end of my presentation. Thank you.
Thank you very much, Dr. Levant. And you have really very in a simple way, you have taken us from engineering electromagnetics to electromagnetic engineering. The session was really wonderful. I would like to see if any questions are being asked. So I request all the attendees, if you are having any questions, please type in the Q&A window. However, I am seeing in the chat window a lot of positive feedbacks about you, excellent overview, and nice presentation.
Thank
so all
you.
kinds of feedbacks are there, and it was really awesome presentation. I can see in the name of electromagnetic engineering, if you start asking students, do you like that subject, they will simply tell, no, we don't like that particular subject. But you have presented in a very nice and simple way.
You know, when I was a student more than 35 years ago in my university, I used to hate electromagnetics. Then I became an electromagnetics professor. So if the students want,
I think it is.
Okay, if the students want to discuss their own problems there from the audience, they can also send me an email and explain their problems.
Sure. Yeah. So that will be really nice. And anyway, you have shown your email ID as well as we are having. We can redirect those questions. Yeah.
It's easy to contact with me via emails or phone. All my correspondence information is there on the internet. Yeah.
So I will take only one question.
Okay.
So what are the possibilities to harness electricity differently using EM from sun? So this is the question.
Could you repeat, because I couldn't hear it?
What are possibilities to harness electricity differently using EM waves from sun? So she is asking that whether the EM waves coming from sun can be harnessed to produce electricity.
There are studies on that. There are projects, as far as I know, on that. We can harness electricity from every possible sources, natural sources, but it's not easy. It's I think it's in their early stages.
Thank you, Professor Levant Sergi. Thank you very much for your time, and we are really happy and honored to have you. And you have made really awesome presentation. Thank you very much. Now we will quickly go to the next keynote speaker, Dr. Ashutosh Datta. I can see he's already there, present with us.
Hello.
Hello, sir. Good morning. I know there is a morning for you there.
Yeah, it's a sunny morning.
Yeah. Yes. So I would like to introduce you to all our audience. So friends, Dr. Ashutosh Datta is currently Senior Scientist and 5G Chief Strategist at the Johns Hopkins University Applied Physics Laboratory, JHU APL. He is also a JHU APL Sabbatical Fellow and Adjunct Faculty at the Johns Hopkins University. His career is spanning more than 30 years, includes Director of Technology Security and lead member of technical staff at AT&T, CTO of Wireless for Nixon Incorporation, Senior Scientist and Project Manager in Telecordia Research, Director of the Central Research Facility at Columbia University, Adjunct Faculty at NJIT, and Computer Engineer with Tata Motors. He has more than 90 conference and journal publications, 3 book chapters, and 31 issued patents. He has co-authored a book titled Mobility Protocol and Handover Optimization, Design, Evolution, and Application. As a technical leader in 5G and security, he has been serving as the founding co-chair for the IEEE Future Networks initiative that focuses on 5G standardization, education, publications, testbed, and roadmap activities. He also serves as the IEEE Communication Society DL from 2017 to 2020. He has served as the general co-chair for the premier IEEE 5G World Forums and has organized more than 65 World Summits around the world. He has served as the chair of IEEE Princeton Central Jersey Section, Industry Relations Chair for Region 1, MGA Pre-University Coordinator for IEEE MGA, and Vice Chair of Education Society Chapters of PPJS. He served as the Director of Industry Outreach for IEEE Communication Society from 2014 to 2019. He was a recipient of prestigious 2009 IEEE MGA Leadership Award and 2010 IEEE USA Professional Leadership Award. He currently serves as member at large for IEEE Communication Society for 2020 to 2022. He has obtained his BS in Electrical Engineering from NIT Rourkela, MS in Computer Science from NJIT, and PhD in Electrical Engineering from Columbia University, New York. He is a fellow of IEEE and senior member of ACM. So, with this brief introduction, floor is yours.
Thank you for
presentation for next 25 minutes, so that we can have at least 5 minutes for Q&A. At least one or two questions I would like to take. Yeah.
Okay. Thank you. I appreciate for the kind invitation, organizing committee for the kind introduction. So I should be able to share now. I don't think. Can you give me the presenter right, Dr. Mishra?
Yes. Now it is given.
Okay. All right. So let me just get this thing up here. Can you see? All right. Can you see my screen?
Yes.
Okay. Hello, everybody. Again, I'd like to thank all the panelists. Honored to be part of this group. And I think you gave a very long introduction. I'm an IEEE volunteer to begin with, so very happy to be a part of this program. So my talk, I'll be focusing on 5G beyond networks and go deep down a little bit into the security aspects. So for those who may not have any specific idea about 5G, so I'll spend a few minutes just to give you some high-level overview of what 5G is and why we need 5G, right? As Professor said in the previous talk, as an engineer, we need to have a reason why we need a new network, right? So I will tell a little bit about that, why we need something like 5G and beyond. Then I'll get into threat taxonomy and security use cases. I'll spend some time around future network initiative that I'm serving as a co-chair. So primarily, if you look at for last 40, 50 years and type of application we have been using, right, things have changed, starting from few kilobit per second, bits per second, text message, email, we have been doing lots of multimedia. And now if you look at the galaxy of application that I'm showing, each of them has a different key performance indicator in terms of latency, bandwidth, system control, flexibility, adaptability, etc., right? So in order to support this kind of application, you need a network that has to be dynamic, flexible, and on demand, you can program it, right? So that's where we have been evolving from 1G, 2G, 3G, 4G, which are the cellular aspects, right? And now we have other dimensions, not only bandwidth, but system control and latency. And that's kind of the driving factor why we keep evolving new technology, new network, and new devices, etc. Right? So with that in mind, how is it going to help us, right? End of the day, we are the end users who would be really taking advantage of new application, new network. As you can see, it's all pervasive, right? It's going to be helpful in our home, robotics at home, on the road, intelligent transportation system, e-health, smart grids, etc. And if you see each of these verticals, again, they have their own new KPIs. Some of them need high bandwidth. Some of them need low latency. So we have to design a network, and that's why we are evolving towards 5G type networks, right? Just to give you motivation. So a little bit of history, right? Some of you may not know how it evolved. So it all started with analog in 1980. Then every 10 years, there has been an evolution of a new cellular network. And you see the 3GPP and 3GPP2, those are the standard bodies. So 3GPP2 was based on Qualcomm IS-95 CDMA 2000. Around 2010, 3GPP2 merged with 3GPP, and LTE, the long-term evolution, actually was born. And then since then, now we're in 2020, we are seeing the early deployment of 5G. And I'll get into what 5G is. But to put it simply, it is not only increase of bandwidth, and there are other dimensions like low latency, massive sensing, massive control, flexibility, and adaptability. So those are the additional tenets or axes that differentiates 5G compared to the previous generation like 4G. So things I showed is mostly on 3GPP, cellular revolution, but at the same time, we all using Wi-Fi, right? So we should not forget that. So Wi-Fi and the cellular, they kind of go hand in hand and complementary to each other, right? If you're in a hotspot like Starbucks or Panera Bread, you're using Wi-Fi, get out of that, you switch to 4G or 5G type network, or maybe 3G at some point. So that is, they always have to coexist. And people who are doing research, they should be really looking into what is happening in these two standard bodies, at least on the enterprise side and cellular side, right? And this is a slide I got from Gerhard Peitweiss, who was the first co-chair for Future Networking Initiative. So how 5G is different, and I know lack of time, so I just go very high level. You might be wondering how 5G is different than traditional 4G. So it is a complete ecosystem. You are changing the radio access technology with new radio type, millimeter wave. Obviously, you can have lower bandwidth as well, and that gives you lots of bandwidth. But at the same time, your range is also limited, right? And the penetration problem as well. Massive MIMO, because of the millimeter wave, you have lots of cells. It will complement the existing fiber technology because you can really use the backhaul and replace that with millimeter wave where fiber is not possible. Then you come back to the core side. These are the dynamic adaptability, programmability, flexibility that are being added. Things like software-defined networking or network function virtualization. You're cloudifying your radio access network. Then network slicing gives you the ability to provide priority service from end to end for emergency communication. ACE Cloud gives you lots of ability to provide low latency applications. So these are some of the enablers that helps to build the core. And then they have other things like heterogeneous access networks, moving between different types of access networks, device-centric architecture, machine-to-machine type communication. So these are some of the very high-level kind of enablers, and depending on the type of application you use, you can use one versus another, right? If you're using low-latency application, you might be using ACE Cloud. If you want to give priority service, you probably have to use network slicing. So you can adapt your network and design your network according to the application that you are going to provide. So what is happening in the standards? This is on the right side. What you see is something from ITU. They define different KPIs, in terms of traffic, capacity, energy efficiency, latency, mobility, and the one on the periphery. Those are the ones people are looking to 5G and beyond. And one on the left-hand side is something that is being developed in 3GPP. As you can see, there are different phases. So initial phase was focused on massive bandwidth type application, right, where enhanced mobile broadband. And then phase 2 and phase 3, they're looking into ultra low latency and massive machine communication. So this is where they define the actual standards that will support this kind of application, right? And each of these, if you can see, I'll go to the next slide, will be more pertinent. They have the different KPIs. So this is an interesting example where you see the different axes, right? You have bandwidth, you have latency, you have a system control. So depending on which specific application you choose, you know that KPIs that are needed, and then you design your network accordingly, right? For example, if you take virtual reality in the top right quadrant, you need a lot of bandwidth and also low latency. On the other hand, if you need industrial automation, maybe you don't need that much bandwidth, but you need low latency. So if you see things which are outside this 4G quadrant, these are the applications that really mandate 5G type enablers. So this kind of gives you an idea that if you're supporting this SMS or email type, you may not really need 5G. On the other hand, you should have the flexibility to support things like virtual reality. So that's where the dynamicism or flexibility comes. So you have the ability to add new enablers on the fly as your new application keep on adding. So now I'll get into the security, but this kind of sets the stage, application, KPIs, network enablers, then you design your network. But at the same time, you also have to make this secure, right? And then I'll get into the security on that. I didn't talk about the actual frequency band, right? I spoke mostly about millimeter wave, but around the world, people have different frequencies, right? You see some of the millimeter wave like 24, 28, 37, 40, and people are getting into terahertz type or with dynamic spectrum for 6G. And some cases you have low band or mid band, and that gives you lots of range. But the millimeter wave gives you low range but high bandwidth. So depending on the suburban, urban area, city area, you can decide, right? Each country have their own regulatory aspects too. So now that you got a little bit idea about 5G, how do we make it secure, right? And security is always a trade-off. If you want to authenticate, that adds time. You want to encrypt, that adds overhead. So it is almost like some of the KPIs that we need will be kind of hampered if you really want to make it secure. So this is an interesting challenge. How do you optimize the security at the same time, don't compromise the security, at the same time, you provide those KPIs, right? So that means it really needs a detailed look and systematic approach. You cannot just do ad hoc security design. When I used to be at AT&T Chief Security Office, we had to work with the vendors, standards community as we're evolving the network. And we had to write these requirements right from the get-go. You cannot just wake up and say, okay, let's design the security. So what you're seeing is a very abstract view how to approach, right? And when you're moving from 4G to 5G, so you still have some, if you look at the Venn diagram, there are existing security threats that you need to think about. You're introducing new threats, and depending on which specific vertical you're looking at, either agriculture or e-health or telco, you look at that specific overlapping area, and those are the things you need to focus. And then at the same time, as an opportunity, you see that hole there. When you add in new technology, it is not only the challenges, there are opportunities also that you can take advantage of. So these are the high-level principles that you have to keep in mind when you go and design your security for any new network or new. So what I'm showing here is some of the bullet items. Those are from ETSI, NFB Security Expert Group. I was very much involved when I was in AT&T. So these are the new types of security pillars that you have to look into because you're adding new enablers, right? So I will be giving a little bit more clear later on, but let me see when you say 5G and what are the threats. So this is a systematic way of looking into, right? What you're seeing here is an end-to-end 5G network. You have end users, applications, you have G Node Bs, which are the RAN network, you have edge cloud to support ultra low latency application, then you have data plane, user plane, control plane, which is a deviation from 4G, and then you have Wi-Fi type network, roaming partners, internet, etc. So if I want to see how the threat look like, where the threat might come from, it could come from the end users by way of flooding or denial of service attack. Somebody may jam my network. Somebody may attack physical in G Node B or go there and change the configuration, the management configuration. Then you have this mid-haul, backhaul, front-haul type thing where people may do man-in-the-middle attack, right? Eavesdropping. And then if you go back to edge cloud, remember that is another enabler to support low latency application. Typically, there are lots and lots of edge cloud around a 5G core because you need to support low latency, right? So there you have a third-party application, mobile edge cloud server. So platform security, because you're sharing the same hypervisor or container type security, right? And then you have attacks from the Wi-Fi type networks, right? Because sometimes that's also important to consider. Then you have insider attacks. That's a very important challenge. You need to think about what kind of protection, security control you have, and logging mechanism to see who is making changes. Then you're adding new things like orchestration SDN controller to make the network more dynamic, right? So a lot of these things are done through API. So how do we take care of northbound, southbound API not getting hijacked? So you need to think about that. And then you have internet side. I talked about on the subscriber side. Although there are firewalls, sometimes attacks may come from the internet side. And finally, you have things on the roaming partner, right? You may be roaming to a different country or different parts where your home network is not available, so attacks may come from there. So this is kind of a very high-level approach, how to look into it. So you open up the network, look at each component, control plane, data plane, user plane, interfaces, and look at the type of attacks. So once you do that, what is the next thing? You have to have a systematic approach, right? So what I'm showing here is one example of how a network may get compromised, a loss of availability, confidentiality, integrity. Somebody can lose, take control of your network, theft of service. So these are different types of security attacks. And then if I'm a hacker, I have to think like a hacker. Then I see how can I do that, right? How can I make the network unavailable? I can flood a network interface that you saw. I can crash a network element. I can change the traffic in between, the man in the middle attack. I can control a specific part of the network by sending some kind of a, having a protocol flaw or fuzzing attack, things like that. So what I am seeing on the description here is how a person can do that, right? A different way to pose that threat. Then you apply your risk management approach, look at the potential risk, how much probability of attack, how easily it can be done, what is the risk I have. You put all those together and come up with a utility function, and then you figure out your security control, right? Depending on if I have a HSS, it has to be more secure than, let's say, S cloud, things like that, right? So this is how you proceed. Now, what I'm showing here is some of the controls, around 5G security, around 5G network. Due to the introduction of some of the elements like Cloud RAN, SDN controller, your orchestrator, network slicing, people are getting into open source. So you have to go deep down from each of these and see what are the opportunities and challenges I'm getting, right? And I'll give 3 examples just to make it a little clear. But this is how you differentiate the potential enablers and then go deep dive into the actual problems, right? But at the same time, there is also opportunities. And what I'm showing here is a closed loop automation, okay? So because you have an orchestration, because you have an SDN controller, you have a data analytics, these are different kind of security function virtualization, like DDoS, IDS, and IPS. So denial of service, somebody detects the denial of service attack on the control plane or data plane. Once you detect, you need to know who is actually attacking it. You turn on your intrusion detection system. You find out the MC, IP address, MEI. And after that, you turn on your firewall, and then you stop the attack. So if there is somebody attacking on the control plane, data plane, you have the ability to detect and do a closed loop automation and detect and quickly stop that, right? So now let's get into, that's an opportunity, right? Now let's get into some of the security problem in the Cloud RAN. And I'll show this picture, then I'll get into the next slide. So the idea is if you have Cloud RAN, your hardware and software, your RRS and BBU are separated, control plane, data plane. So you have tons of attacks could come from the IoT, billions of IoT devices. So how do we, if that is a problem, it has opportunities because Cloud RAN, what I'm showing here is the opportunities or capabilities, because Cloud RAN has lots of new capabilities, and on the security side, you're also getting a lot of benefits, right? Because of Cloud RAN, because you can embed your DDoS detection function, scheduling, the separation of control plane, media plane, but at the same time, it introduces a lot of security challenges, right? How do you, once you figure out that you're getting benefits, but there are challenges, then how do you take care of the actual mitigation, right? So this is an example of Cloud RAN. Similarly, I'll give another example of mobile edge security. So we are putting edge cloud to give low latency application, but at the same time, it has to be secure. So if you still want to authenticate yourself at the core, it's going to take a lot of time. So the idea is you probably have to store some security context at the edge. But by doing that, you're increasing the vulnerability, right? So you are getting some KPI, but at the same time, you are losing the trade-off and in terms of KPI. So how do we take care of that? Because I'm reducing the latency, but I have to take care of this, the vulnerability because of the security context. Those are installed in the edge cloud. So what you do the similar analysis. You figure out what are the potential opportunities by having edge cloud. That's pretty clear, right? And then if I put the security context at the edge and do a security association at the edge, what are the challenges I have? And then you figure out the potential mitigation technique, right? So this is another example of mobile edge cloud, second enabler. The third enabler is the slicing. So what is the function of slicing? What I'm showing here is slicing gives you the ability to set up end-to-end resource reservation, right? Based on a critical communication. Let's say emergency communication. You need lots of bandwidth, memory, CPU, etc., so that your PO is maintained. But if you do that, that is an advantage. But at the same time, the slicing, because of the virtualization, one slice may attack another slice. It may take the resources from another slice, or one endpoint may be connected to multiple slices, and that may be a potential source of attack. So while slicing gives you the opportunity, there are security concerns in slice that one needs to think about. And this is an example of similar thing for slicing part. What are the new capabilities slicing provides, and opportunities from the security point of view. And then what are the potential risks and potential benefits, right? I sent the slides to the organizers. You can take a look at it. Because I want to remain within the time just to answer questions. So I gave 3 examples of the enablers: Cloud RAN, mobilized cloud, and slicing out of those 10 pillars I showed. And I try to give an idea about the capabilities, opportunities, challenges, and potential mitigation techniques. So what's happening? There are tons of standards bodies people are working. I have listed few of those. Many of you are probably following that anyway. So ITF, 3GPP, and they have their own roles. I'm very much involved in IEEE. I used to be involved in ETSI. And then there are tons of these open source standards, right? You can build your own 5G type testbed if you get involved any of these standards bodies. And then there's ITU, and there are different regulatory aspects, right? So what I'm showing here is there is a interesting opportunity for people to follow what's going on in 5G. And if you want to build your own testbed, etc., you can do that. And this is just an example of a testbed that I was heavily involved in building, right? So you can have different kind of, talking about security, let's say, different kind of IDS, IPS, and do dynamic service chaining. The example I showed, you can have IMS for application, you can have emulator, etc., right? So this is how you can get involved. I will probably skip that. I wanted to show that you can really still build something, have an emulator, and do some kind of closed loop automation, trying to send malicious traffic, and 3 use cases I'm showing, and how do you detect and how do you block it, right? So this is just a very simple example of detection and mitigation, and I'll just go through it. This is one example where you detect blacklisted URL and you stop it. Second thing is you detect malware being going through your network, how you detect it and mitigate it, using security monitoring. And this is the third one, which is bandwidth overload, and somebody is not supposed to send lots of traffic, but you detect which specific application, which subscriber, IP address, MC. Once you detect that, then you have the ability to block it, right? So this is an example of this closed loop security automation. Spend 2-3 minutes on this. How do you get involved in the Future Network Initiative, which has about 15 different roadmap working groups. Tim Lee is one of my co-chair. Brad Closer is the staff director. So Future Direction Committee has several different initiatives, and Future Networks is one of them. So depending on which one you may like to get involved. There are about 22 societies. Obviously, you see antenna propagation is one of them who are contributing to this. There are many stakeholders. It was launched in August 2016. We had a first meeting at Princeton University. There are other activities, and many of the members, including Puneet and other organizing committee members, they are part of this actually. So there are a lot of things, not only standards, publication, tutorials. If you want to get involved, please let us know. These are different working groups. Each of them have chairs, and many of them actually from Bangalore section as well. Rabi is there. And then on the roadmap, this is the website, by the way. You see the 5G World Forum that was supposed to take place in Bangalore at 10 through 12, but now it is being virtualized. So obviously, a lot of organizing committee members from Bangalore section like to thank them for putting their heart and soul to make this success. So please do register for that and try to learn more things there. This is the roadmap working groups. Depending on your specific interest, you can join any of these, right? So what we're doing is we're taking a 3-year, 5-year, 10-year roadmap to develop technology that could potentially be used by 3GPP or the standards at some point, because IEEE is supposed to be the visionary guys, right? So we have 15 different working groups. There are co-chairs. If you like to get involved, we had a roadmap readout 2 weeks back. If you go to the website, you can take a look at the slides and recording. So depending on your interest, expertise, IEEE is open, neutral platform. You don't have to be a member also. We encourage membership, but you can, and there is a white paper out there as well. We published in December 2019, and there are other white papers. There is something called Connecting the Unconnected, which Sudhir and I are working on that, or taking care of people who are in disconnected world. AI ML is a new one that's coming into 6G, systems optimization, etc. Right? So so finally, I have just last more slide. So this is a solicitation or welcome to people who are watching it, who will be watching it, to take advantage of this thing and join IEEE Future Network Initiative. In summary, when you have to think as an engineer why it is needed to have a new network, it's because of new services and applications, they have new KPIs, and then you have to look at the end-to-end view. What are the key pillars, key enablers, security opportunities, and collaboration important. Operators, vendors, researchers, student community, they all have to collaborate, try to build some test bed you can do, then go back to standards, iterate it, and different use cases. You have to also work with the regulators. So thank you and join us for the Innovation Revolution. I think I left only a few minutes, Puneet, for you to ask any questions. Sorry about that.
Yeah, so anyway, you have made a very, very nice and exhaustive presentation on 5G security. So definitely we don't have any time for question, but I would still like to ask you, we are going to have a 5G World Forum this time virtually, which was supposed to happen in Bangalore. So what are the topics you are going to cover, and whether it will be really useful for the participants? You can just share your thoughts and information about that 5G World Forum, which you are co-chairing.
Right.
So it will be really useful for them and they can join us.
Yes, absolutely. So the call for paper just got over. We are in the process of reviewing that. There will be 12 keynote speakers. We already have 6 confirmed. There are industry, academic, world experts. And we also have about 14 different tutorials, about 10 different workshops, and then topical verticals, about 10 of those. So please keep an eye, look at the website. And Bangalore Section, and overall India Council, they have done a great job in trying to help move it. Hopefully we'll have it in person next year at Bangalore. We are trying that. But you can feel free to get back to me as well. Any other questions? Thank you, Puneet.
Yeah, thank you, Dr. Asutosh. Thank you very much. I will take only one question. There is a question being asked: how does Cloud RAN prevent DDoS? Okay,
good question. So when you see Cloud RAN, you have this data plane, control plane. Obviously, they're changing. Then you have the RRH and BBU, and so the radio head stays there, but BBU part you have the ability to put it in the cloud. So what is happening now, because of the software and virtualization, many of these firewall vendors, DDoS vendors, they have this virtualized software. And when I was in AT&T, we started doing that. So you can actually embed as an agent in some of those virtualized. So you can look at the east-west traffic, north-south traffic. So by doing that, you can actually detect the security attacks right at the edge. You don't have to go wet into the core, wait for the core to detect that. So you have an early detection right at the edge. So example I was showing, that is the advantage. But at the same time, there are challenges because if lots of attacks are happening, you can spin up additional virtual firewalls. That might get the resource, steal the resources from other DNFs, right? The actual Cloud RAN DNF. So that is some kind of a mitigation technique you have to do there.
Yeah, thank you. Thank you very much, Dr. Asutosh Datta, for sharing your perspective on 5G security. Now we really don't have time to take any other questions. So we will be moving to the next keynote speaker.
Thank you.
Thank you very much. Next keynote speaker is Dr. Kamesh Namuduri. So before giving the floor to him, I would like to read his brief bio. Dr. Kamesh Namuduri is a professor of electrical engineering and the director of Autonomous System Laboratory at the University of North Texas. He received his BS degree in Electronics and Communication Engineering from Osmania University in 1984. MS degree in Computer Science from University of Hyderabad in 86, PhD degree in Computer Science and Engineering from University of South Florida in 1992. Over the past 11 years, his research is focused on aerial networking and communication. He has co-organized a series of workshops on airborne networking and communications in conjunction with IEEE, AIIA, AU, VSI, and ACM conferences. He is serving as the chair of 2 standard working groups, IEEE 1920.1, Aerial Communication and Networking, and IEEE P1920.2, Vehicle-to-Vehicle Communication for Unmanned Aircraft Systems. He is serving as the chair for the IEEE Vehicular Technology Society's Ad Hoc Committee on Drones. He is a co-editor of the book titled UAV Networks and Communication. He is leading the smart and connected community projects on deployable communication systems in collaboration with the government, public, and private organizations. This living laboratory project was demonstrated thrice during the Global City Teams Challenge hosted jointly by National Institute of Standards and Technology and US Ignite in 2015, 16, 17, and 18. He contributed to the development of research agenda, requirements, blueprints, highly deployable communication systems led by the National Institute of Standards and Technology and the National Public Safety Telecommunications Council. Friends, we were supposed to challenge in this particular CONECCT, but because of CONECCT went to virtual, we could not have that challenge. We have shifted that challenge to our next conference. Let us see whether it is possible to conduct in that particular conference also. Otherwise, Dr. Kamesh was really kind enough to provide sufficient support financially to fund almost 6 teams with $500 each for demonstrating UAV to UAV communication. So his talk will be mostly covering those information. So this you can listen very, very carefully, and then you should try to demonstrate and participate in that particular challenge. Dr. Kamesh, over to you.
Thank you, Puneet, for this great invitation. It's an honor to be here and talking to all of you. It's also a privilege and honor to be with the panelists. I heard wonderful talks, both from electromagnetic perspectives and 5G perspectives. Yeah, it's good to be with you. I'm going to share my presentation. This talk is about over-the-air direct UAS to UAS communications and its relevance or importance in traffic management. Now, the whole world is actually getting ready for using drones for a variety of applications. Some of the applications are already there, but more interesting things are going to come. For example, almost like taking people from suburban areas, for example, to the airports, using totally unmanned aircraft systems. So there is a lot of exciting work, but there is also a lot of preparation going on. And fortunately, I've been currently involved in a couple of interesting projects. One of them is NASA's Urban Air Mobility project. So I'm going to share my experiences, both current and the past. I'm going to show a couple of videos to just showcase, how these tests are being done. One is actually a simulation. The other is actual footage of a small flight test that we did in August during summer 2019 as part of UAS traffic management experiments. So I'm from UNT. You heard a few things that I'm doing currently. And the main thing that I would like to highlight here is I serve as the chair of 1920.2 vehicle-to-vehicle communications. And this work is still going on, and I'll talk more about that. So first of all, let's look at the context. Unmanned air transportation. So why do we need, and what are the expectations, especially from a societal point of view? One is traffic. I think anything that can help us to reduce congestion. For example, the recent trips in Bangalore, it took me 3 hours to go from a local area to airport. So anything to cut down the congestion is very, very welcome, obviously. And then at the same time, the unmanned air transportation is expected to reduce accidents, reduce the commute times, and there are several other benefits. For example, environment pollution is expected to be less if you do it right. And then the most important thing is emergency services. It will be nice to see what I call a medical help in few minutes when we really need it. In some cities, like for example Dallas, where I live, typically it takes about 5 minutes, less than 5 minutes you can get an ambulance service. But think about a rural area or congested areas like for example in Bangalore or any busy cities. it is difficult to get service, medical help in quickly. So here is an opportunity for us. Unmanned air transportation is expected to cut down the turnaround time significantly for emergency services. As for other things are like business, package deliveries, even though they're not critical, yeah, people nowadays want everything in the same day or maybe in half an hour or 1 hour. More important applications include critical infrastructure monitoring, and the main thing is this unmanned air transportation is going to increase the speed of the mobility. In summary, actually, I would like to say here is a major lifestyle changes are expected. And these are all expectations. So are we ready for such things? How do we prepare for them? So these are the things I would like to cover. So here are the challenges and opportunities. In terms of technologies, infrastructure, and initiatives, the primary thing is the world is, entire world, all civil aviation organizations are currently working on what we call UAS traffic management. It comes in many words, like for example, UTM, urban air mobility, or UAM, advanced air mobility, or called AAM, global UTM. These are different names, but the main thing is how can we integrate drones with commercial, for example, national airspace. Every country is working on. Obviously, you will see a lot of news a lot of news items. Like for example, in India, the initiative is called Digital Key Ecosystem. So Digital Key is a digital sky actually. Digital Sky is the name of the program that Indian government is working on. In the US, NASA is leading this initiative with support from FAA, with collaboration from Federal Aviation Administration, and a project was completed that was called UAS Traffic Management, and now it is kind of evolved into what we call Advanced Air Mobility National Campaign. And so that is the key thing. We need to come up with a proper traffic management system. And then also you need to platforms. So how do you design different kinds of platforms? For example, electric vertical takeoff and landing. In Dallas, we have Bell Flight. So it has developed a wonderful platform, and there are so many startup companies which are working in this. Basically, the platform is supposed to be capable of delivering packages, obviously. At the same time, even taking a couple of people, maybe one passenger or two passengers, completely automated platform, and that it is expected that maybe it should take us from short distances, like for example 30-40 minutes distances, like for example going to airports. And then instead of what we call airports, we have vertiports. I'm going to show an illustration of how it looks like, and lots of sensors, because automation is the key here. And then a lot of technology have to be developed in terms of power, like how do you keep the flight for a long time in the air, communication, and all that. And interestingly, public awareness is a big bottleneck. So you know that when you introduce self-driving cars, not every community appreciates. And think about a drone flying in our communities, and think about imagine the noise that you might expect. Plus, so in fact, when we recently had a discussion, noise seems to be the most important factor for bringing the drones into the communities. Nobody wants to hear lots of buzzing sounds. So how can you minimize the noise, and how can you make sure that it doesn't cause disturbances to people in the communities? And obviously, along with that, safety, trust, and privacy issues are also very important. And how do you bring this awareness into public? That's an important issue. And then regulations. Even though you are seeing lots of news, there are some drone has delivered pizzas here and there, or even the most recent news is like CVS, for example. During COVID, CVS partnered with UPS and delivered what we call medical supplies. So all these are under test. They note that none of these are ready. In fact, regulations are not yet there. All regulations are not there, which means that unmanned air transportation is still is evolving, and there's a lot of technical work that is being done to help the civil aviation organizations like FAA to come up with the regulations. And obviously, there will be a lot of legal aspects that need to be addressed. So in terms of technology and from a student perspective or a researcher point of view, how can you engage in research? Here are some of the topics. Software-defined networking, we just heard in the 5G talk by Ashutosh, and ad hoc networking, public safety, emergency communications. In fact, along with Ashutosh, recently a committee was formed by IEEE Communication Society focusing on public safety communications. And I am also a member of the team. Traffic management, and we're going to take about 10-15 minutes on the vehicle-to-vehicle communications very soon. And then artificial intelligence is called edge computing, also is very relevant for the drones. Mostly, the last but not least is human autonomy teaming. Just like the way in robotics, we want to create robotic teams and then work with the teams, create partnerships between robots and humans. Even with drones also, human autonomy teaming is an important area. So just for reading the economic factors, there are two reports that were what we call promoted by NASA, or rather publicized by NASA, Crown Consulting and Booz Allen. And look at the number actually. What kind of applications we are expecting? Airport shuttle, air taxi, air ambulance. And then because of the market, all these market drivers, the potential market is about 500 billion in the next 10 years. So obviously, everybody wants to, especially the companies, startup companies, are vying to get a share. In fact, last November, when there was a advanced air mobility first meeting by NASA, 400 companies attended this meeting. So in terms of, obviously cities have to support. Particularly three cities are showing a lot of interest. One of them is Dallas, so this is where I live. Los Angeles is another city, and Singapore, and there are a few other cities are getting ready to encourage advanced unmanned air transportation into their cities. Here a quick, these are real pictures. The left side is what I call a vertiport in Dallas. And the right side is a bigger view. There is another rendering, artist rendering, to showcase how unmanned air transportation is going to be what I call supported by vertiports. So these are the rooftops. You can see, like from the rooftops, the vehicles are going to take off from one rooftop to another rooftop, and that's how the traffic is going to be. This is actually some view. On the right side also is just another vertiport view, but remember these are artist rendering; these are not real. In terms of readiness, it's very expensive as of now. Economics is very high. Initial expenses are very high. Weather impact of weather is very significant on drones. A lot of work has to be done. As I said, air traffic management also is still evolving. Battery technologies also we are not ready to have longer flights. Even though you're seeing cross-Atlantic experiments, they're all still in laboratory experiments. And the impact on energy and environment still has to be studied deeply. Getting into technical stuff, here is an example of what we call UTM architecture. And this is from NASA, by the way, courtesy from NASA. I want to showcase some important things here. For example, UAS stands for Unmanned Aircraft System. So this is what we call UAV. Whether you call UAV, UAS, or drone, they're one and the same. And look at the communication part that we are spending. I'm going to talk about. B2B communications is a direct communication between UAS to UAS. And obviously, the traffic management system is what is called UAS service supplier. These names are not so intuitive. Today they call what they call PSU, provider of services for UTM, PSU rather. So this is the central piece. UAS service supplier is a traffic management system, or the central piece of traffic management system. It talks to flight information management system from, for example, FAA. It talks to public safety, and lots of services, supplementary services. And there is a human being involved here, US operator. So this is what is called a UTM ecosystem. This project was done in 4 levels. It was completed, and it kind of evolved automatically into advanced air mobility project. So this is a snapshot of advanced air mobility, illustration of advanced air mobility that has started recently, and it is going on as we speak. And the idea here is, how do you start with a simple flight from, for example, a drone going from A to B, and then how do you handle emergencies, contingencies? For example, let's say there is a fire in some place and you have to avoid, or the weather is bad, you have to avoid. So how do you address all these issues? So the private segment, the private companies have a lot of role to play. They need to develop products, and all these things are, in fact, just started. Advanced air mobility project just started. It's going to take a few more years in the US. In India, the system is called Digital Sky Ecosystem. I just put this picture, even though it's not so clear. But look at the ecosystem is very similar to what we have in the US as well. So basically, it's all about traffic management and handling emergencies and handling the hazards like weather hazards and communication failures and all those things. So all these things have to be part of the traffic management system. So now coming to the crux, vehicle-to-vehicle management, vehicle-to-vehicle communication. What do we mean by that? This is a nice illustration here. 2 vehicles. As you can see, maybe let's see this as a ground control system. Here you have one UAV, and you have another UAV. So what happens is when they are on flight, it is not possible for all the drones or for the ground control system to be within the communication range, or the drone may not be within the communication range with the ground control station. So then what do? You need to use some sort of a networking. Maybe like in this case, one drone can talk to another, and then use this drone as a relay to communicate with the ground control station. Now the question is, how can you accomplish this? So I'll ask a simple question to just make my point clear. Suppose you are attending a conference. Imagine that this CONECCT conference is going on in real, not virtual. Then you see a friend. So how do you talk to him? Do you say hello directly, or you want to pick up a cell phone and ask him, call him on the phone, or maybe you want to use a satellite, a LEO satellite or GEO satellite to reach out to him? The answer is very simple. When you are very close, you can talk directly. You should not be using you don't need cellular network or a satellite network. But of course, all these are complementary techniques. All 3 are important, but depending on the scenario, especially when you're so close that a collision is going to happen, then you don't have time to even communicate with the cell phone, the cellular network. So that is the point I would like to drive here. All 3 are complementary. You need all 3 technologies, but depending on the scenario, you may need one is preferred to other. So now going into a little more details, B2B communication is required definitely for traffic management, tracking the vehicle, coordination, positioning, positioning the drone or maybe the antennas in a proper way so that you can mitigate the interference, and finally, or in the process rather, beyond visual line of sight or beyond radio line of sight communications, relaying, routing, and many other applications. And you have 3 candidates, obviously: satellite, cellular, and direct. So these are the main ideas here. These are very high-level perspectives. Satellite communication we can use, obviously, unlimited coverage and but their latency is little large. Even though there are products today, obviously, to establish B2B communication using satellite, but again, in general, in principle, the latency is larger compared to other 2. In case of cellular, you have the coverage is medium and the latency is sort of on the average. In direct communication, coverage is limited. For example, if you are using any DSRC or dedicated short range communication or even Wi-Fi, you know that the range is limited. But latency is good. You can communicate fast, and there are big challenges though. That is what I also want to emphasize. That when the vehicles are moving fast, like 200 miles an hour, for example, and relative velocities can go more than 400 miles. So given that, there is a significant Doppler effect, and we need to study that carefully. Yeah. So in terms of, when I mentioned direct communications, what do we mean? Either use sort of Wi-Fi or maybe DSRC or maybe some other dedicated channels if they are going to be available for us later. As of now, there is no dedicated frequency band for V2V, but the FAA is asking for recommendations. The FAA is looking into, is it required? Is it not? Can we do with? Can we deal with? Can we use only unlicensed band? And can we have V2? Can we have such communications? So all these are in discussions. But in terms of UAV to UAV model, the main thing is, from an engineering point of view, we need to understand the channel. There are some models that you see in the literature, but not enough studies have been done to understand the UAV to UAV channel characterization. So, and this is one of the key things in terms of research that still requires a lot of attention. And I'm quoting one of our colleagues, Rui Zhang from Singapore. So here are the main aspects. Obviously, you can see a good line of sight. So there is a dominated LOS component is line of sight component is dominated. Limited multi-path fading because you are up in the air and there's not much disturbances, much obstructions. High Doppler frequencies also are going to be there. So the key thing is the dominance of LOS links may suggest, you think, oh, we have a good communication and 5G like millimeter wave could be used. However, it comes with some pain points. The high relative velocity between UAVs coupled with high frequency in the millimeter wave band could lead to excessive Doppler shift. So more studies are required. And this is an important takeaway from this. So we have two standards, 1920.1, 1920.2. I'm happy to say that 1920.1 the draft version has been completed. Is about to go for ballot process within IEEE, and by end of the year or early 2021, we expect this to be released. And what is this 1920.1? Aerial communication. So we came up with a framework for creating ad hoc networks of drones in the sky. And what's important is it's very challenging to have a totally ad hoc network. But on the other hand, with some infrastructure, it is possible to create a network. And then while we are working on these standards, we realized I think we need to have first to establish V2V communication, one channel, one link between one vehicle to another vehicle. So the goal here is how do we establish what kind of protocol, what kind of information we can share, what are the use cases. So those are the things we are studying in 1920.2. And related standards, very important protocol update is from ASTM. ASTM is also called American Society of Testing and Materials. Actually, it is a global organization, not just limited to, not within the US. So it has released a standard called Remote ID. It is brand new standard and it's very, very useful. And the Federal Aviation Administration has already kind of blessed it. So which means it's going to be part of real world very soon. But still, it is in the last stages, I believe. But the standard is readily available for those who want to look at it. Then I will skip a few slides because of time, and I'm going to show you a couple of videos. Again, first thing is I'll show the real video first, and then we'll show some animation that I wanted to show. I think I need to stop the share for a second. Then I need to bring another one. So this is a small clip that shows how we actually do the flight test. So in this case, there are two drones, two different places, and we try to see how to test their V2V communication capabilities. This was part of UTM testing that was done in Corpus Christi in 2019 summer. Okay. The second thing that I want to show is a small animation. I'll stop maybe within 2 minutes, but it's also an important thing that I would like to show here. So switching is a little bit challenging. Right. We'll stop in just 2 minutes.
Sure, no problem.
Yeah. Yeah, let's stop here, Puneet. I think that's just to give some basic background. Thank you.
Yeah, thank you, Dr. Kamesh. I think your presentation is over. You hope anything is still pending? Yeah, thank you. So due to paucity of time, I will take only one question and then we will wrap up. Question is, how far the standardization process of ad hoc UAV is reached?
Yeah, as the 1920.1 is the ad hoc networking standard. The draft has been completed. We have worked on this for about 4 years overall, and 2 years very intense discussions. So it is ready to go for ballot process as of sometime in July, early July, and it will be released to public by. It is expected that it will be released by end of this year.
Okay, so I will ask a question regarding to our UAV to UAV challenge, which you have floated, because we have received a lot of questions, what kind of communication you are looking for. So can you just briefly describe about that challenge for 1 minute so that students can participate in large numbers? Yeah. Yes,
please. So the key thing is we want to keep it as flexible as possible. For example, even today, there is no what I call recommended communication methodology for direct US to US communications. So remote ID specifically encourages Wi-Fi, and obviously Wi-Fi has its own limitations in terms of range. So you could use Wi-Fi is fine. The Bluetooth also is encouraged. DSRC, like DSRC, which is about, I think it is 1700 megahertz range, or even unlicensed, any unlicensed band is fine. So like 900 megahertz, for example. Of course, it may have a conflict with the remote control communication channel. So technically, you can use any means of communication, including LTE. If you want, you can use a 4G or 5G devices to communicate. So, so it is completely free. It's completely open, rather, for you, for students to pick any means of communication. And I'll provide more details maybe since we have time later on the offline.
Thank you, Dr. Kamesh, for providing a very, very nice and exhaustive presentation on UAS to UAS communication. And on behalf of IEEE Bangalore Section and on my own behalf, I would like to thank you for joining us and giving this wonderful talk. Thank you very much.
Thank you. Thank you.
So friends, we are now at the last keynote. So we will be having the last keynote by Professor Saifur Rahman. So Professor Saifur, you are there? Yes, I can see you now. So before giving the floor to him, I would like to give a small introduction of him. So Professor Saifur Rahman is the founding director of the Advanced Research Institute at Virginia Tech, USA, where he is the Joseph R. Loring Professor of Electrical and Computer Engineering. He also directs the Center for Energy and Global Environment. He is a Life Fellow of IEEE and IEEE Millennium Medal winner. He was the president of IEEE Power and Energy Society PES for 2018 and 2019. He was the founding editor-in-chief of the IEEE Electrification Magazine and IEEE Transaction on Sustainable Energy. He has published over 140 journal papers and has made over 400 conference and invited presentations. In 2006, he served on the IEEE Board of Directors as Vice President for Publication. He is a distinguished lecturer for the IEEE PES and has lectured on renewable energy,
Professor Raman, you can take over. I think check.
Okay.
Yeah.
Thank you. So can I share my screen? You let me share my.
Sorry, there was, yeah. So there was an outage of power here. Disconnected.
That's okay.
Even in Bangalore, there is outage.
No need to buy. Yeah. Give me screen sharing privilege. I'll share my screen.
Yeah, so friends, I wanted to add at the end that Professor Saifur Rahman is the candidate for IEEE. So it is very, very nice to hear him on his favorite topic of energy internet. Thank you.
Thank you.
I'm making you a presenter. You can get it.
All right. Yeah. It's not here yet.
Yeah.
Okay, it's coming.
I have given you access. Yeah. Okay. Thank you.
So I'm going to make it full screen and get started. Okay. Good morning, good afternoon, good evening, wherever you are. Thank you, Puneet, for arranging this talk for my side. And I'll talk about 2 or 3 concepts here. Energy Internet, I'll define this, sensors, and transactive energy applications. This previous talk from UT Texas, North Texas, interesting because I am talking about some of those ideas about sensor implementation in my talk as well. So going forward, question is, what is the energy internet? we know what is internet very well. Internet allows information to flow from anyone to anywhere or from anywhere to anyone. We know that. We're doing it right now. The energy internet is a vast network. It's being built, not done yet. It's a vast network that will allow efficient distribution of electricity to anyone from anywhere. So I'm sitting in Virginia, US now. You're in Bangalore. Can I sell you some solar power now because it's sunny outside my house here, or vice versa? That's the concept of energy internet. So for that to happen, the EI or energy internet will utilize smart sensors, ICT technologies, and algorithms to facilitate power supply in real time, that's keyword, real time, enhance storage applications, integrate renewable energy into the grid. These are the things we want to do, but cannot do it in full capacity yet. The concept of energy internet will make that possible. That's our expectation. Now, we know all this. Amazon, Alibaba, you can buy and sell goods. You can post your book to sell in Alibaba and Amazon, you know all of that. The difference is energy internet is an online marketplace that transacts in energy. When you say transaction, it can mean one of three things. One-to-one, like I put my book on Amazon and say you buy it from Amazon one-to-one. Or one-to-many, examples here. One-to-one between individual users for bilateral transactions. One-to-many, example, one electric power company sells to many customers. Bangalore, Bescom, local supply company, they sell to Bangalore-based businesses, homes, and so on. Many to one, M2O. Many customers sell to one electric utility, like happening in many places. New Delhi, for example, many rooftop solar people or solar buildings can sell power to the local power company. Those are the options. The difference is here. Unlike Amazon, Alibaba, you order something today, you get it tomorrow, the day after. For our business, it cannot be tomorrow. It has to be now, real time. Simultaneously, all network constraints must be met. Meaning, if too many people are trying to sell electricity from the rooftop solar to the local distribution circuit, it may not work because the circuit may not have the capability to move so much power. So those are the restrictions we have to keep in mind as we build the energy internet. Okay, now, what is the vision for the future grid? And I'll use that vision to justify the concept of energy internet. So future grid is not something totally new or different. It is a concept based on what is happening today. Look at the left-hand side of the screen, electricity production and storage. We have storage, photovoltaics, hydropower, thermal power, wind power, nuclear power. India has all of these, by the way, today. That's the supply side. Then you got transmission side, distribution network, substation, transmission lines, fine. On the consumption side, we have electric vehicles, homes, businesses, industries, factories, consuming power. Then at the bottom of the screen in the middle, I have energy flow, which is happening for 100+ years now. Data flow is new. What do you mean by data flow? We are now, through smart meter usage, looking at the power consumption at every home, building, office in real time. Business flow, this is new. If I have excess solar power from my rooftop output and not using all of that, I can sell that to a neighbor or to the local grid. We call this transactive energy. Those are the new things, but those are established in the existing system. So now, how do I map energy internet into the future grid? Now look at this. We are now moving away from building on the existing grid. If you look at this picture on the screen, the middle part is the grid that exists. You have transmission line, generation, local supply. At the bottom, you got rooftop solar, battery storage, wind energy. On the left-hand side, you got electric vehicle. On the right-hand side, you got power plant, storage tanks, all of that. And on the upper right, you have the transmission line and the oil well, meaning the energy consuming people. All of that is there. Conceptually, we're moving all of that into the cloud, internet. That means what is happening at the control center of the power company today will move to the cloud where all the data will be presented. Now that brings serious concerns about cybersecurity. We'll get to that later on. That's the concept right now. Okay. So how do you get there? If you look at this picture on your screen, we have, first of all, on the top, network today is extensive and interconnected. You know that. India, the whole country is one grid today. Then on the right-hand side, if you go circular, you have what I'm saying, smart and interactive. What do you mean by smart or interactive? You can in real time see what every rooftop solar is producing in real time, and are they able to use that solar energy internally in the building, storing it, or trying to sell it? That's the interaction. Below that is secure and controllable. We just mentioned that security issues. I get back to that later on. What I mean by controllable is happening in the US today. In some cases, rooftop solar, California especially, mid-morning, producing more electricity than the house can use. So they push it to the local distribution network. As a result, because of excess capacity pushed into the grid, the voltage goes up. That means it is not acceptable. We can, in the US, allow plus minus 5% voltage fluctuation. So the power company tries to control those inverters, turn them off as a possibility. Next on the left is flexible and resilient. Flexible meaning if you cannot sell electricity to the grid because the excess supply, you will store it in the battery in the house. And that's a question of economics, other things, get back to that. And then finally, on top of that is open and sharing. That means, I said, all the data on the system is in the internet. You can see on your screen who is selling how much, what price. I'll give you an example in a few minutes. That's what you mean by open and sharing. Okay, now what are the functions of the energy internet? We use the term smart grid. Some countries use the term strong grid. Either way, same thing. You get a grid, you get a source, load storage, the oval on the left-hand side. Then you got on the business side, enterprise operation, grid operation, customer service. What is new? If you look at the right-hand side, new business, big data, TV, cloud. Equipment here is the EV charging station. Energy finance, at what price you buy. Electric vehicle, internet. That is the new business. To make the new business work with the smart grid, the oval at the bottom on the left-hand side, you need sensors, the web platform or the cloud platform, different applications. But all of that has to be ubiquitous, meaning it has to happen without us knowing it. That's the part that we have to be thinking about going forward. So what happens as a result? This strong and smart grid and the ubiquitous IoT, energy IoT, come together, gives us the energy internet. And then you have energy flow, information flow, and business flow going to the network. And then, of course, right-hand side, you got end users, suppliers, internal users. All of those people are users. In the middle, you got the source and the supply. Left, you got the control. That's the architecture of the future energy internet. So just to define it more clearly, I guess, the challenges on the top are three blue boxes. We must have Holographic perception. What does it mean? We must have multi-dimensional, not just three-dimensional perception. Perception for PV. I must know the amount. I must know the voltage. I must know the price. I must know the duration. How long you, my neighbor, want to sell me solar power, at what price, and how is the voltage happening in your place. That means for that to happen, we will provide ubiquitous connectivity. All the homes will be connected to each other. And then on the right-hand side, integrated innovation. That means a lot of things have to happen, as you can tell. This is the concept right now. Issue of financing, issue of communications, reliability, trustworthiness, all that has to work together. So these 1, 2, 3, 4 are the platforms. We must have, number one, intelligent sensor terminal technologies, very robust communication infrastructure, an IoT platform to collect data, and of course, the big thing is information security, which is what I always worry about. Now, so what is the framework then? You have the home area network. We all know what that is. It has home as a smart meter. Then you got neighborhood area network. Multiple smart meter data comes to a collection point and then sent to the utility network. That's what we mean by wide area network or utility-wide network. That has to all work simultaneously, reliably, and without much concern about security. How do you make it happen? Field implementation. You have your home, your business, you got switches, you got thermostats, you got other controllers for lighting control, ventilation control, and so on. You got a monitoring system in the house and the building, monitor the temperature, humidity, occupancy. Based on that, you turn the ACs on and off. That is ending at the smart meter, which is seen by the power company. Power company can talk to your smart meter through landline or radio frequency, internet, fiber optic line, whatever it is. That part of that thing is being built today. So we are not starting from scratch. Okay, so what is then the basic transactive energy process? Okay, look at this thing here. One option here, one way to do the buy and sell of excess PV power. At the bottom, I got 4 circles. One homeowner wants to sell 6 kilowatt hour between 1 and 2 p.m. the given day at a given price. 3 tokens can be 3 cents, 3 rupees, 3 whatever it is, it doesn't matter. Another person put a request on the network. He or she wants to buy 5 kilowatt hour in the same time frame, 1 to 2 p.m., and they're willing to pay 4 tokens. The distribution system operator who has to manage the trading say they would let the price go up to 8 tokens, no more than that. And then somebody else wants to buy 5 kilowatt hour at 4 tokens. Look at the numbers here. 6 kilowatt hour for sale, 5 plus 5, 10 for purchase. That means not enough to buy because only 6 is available. People want to buy 10. What happened? Either they will not buy what they want or they raise the price. So new seller comes to the picture and make it happen. That's the concept. Okay. By the way, this is how the network is operated today at the grid level in the US and many countries. So how do you realize this? You have to have three things have to happen. You focus on the middle part of the picture on your screen. The orange box, EV trading, DR trading, and data analytics. EV trading, we talked about this. DR trading, DR stands for demand response. That means somehow say, okay, they want to buy 10, 6 available for sale. I am a building owner. I can reduce my demand by 4 kilowatt hours the next hour. And as a result, I can reduce the demand. So the 4 kilowatt hour shortage, 10 minus 6, is made up by me reducing my demand. I get paid something about this. The 3 components, and here I'm talking about wise building, wise grid, wise market. These are actual things happening today. A project run by a company called BEM Controls. website at the bottom. They have a project, you go to their website, get more data. I don't have enough time to explain this, but that's happening in real time today. Now, so this is the data. This is a microgrid in Chicago, which is being used as a test bed, where the energy internet, the wise grid, keeps track of the network security from power consumption viewpoint. Wise market is the bidding process we talked about. And the wise building is the platform every building has to see what they are using, how much they have in solar, how much they have in storage capacity, can they do some demand response, all that is going on to make the internet of energy practical. So now an example here. This is my building in Virginia. We have rooftop solar. So we are saying we will become a prosumer. We are a participant in the energy internet. Prosumer means I purchase and I produce and consume both. Produce meaning rooftop solar, consume meaning I buy power from the grid. So building owners have that information. DER owner could be, they can reduce demand, or they may have a solar on their roof or field-based solar, which can produce power for the grid. And DSO is the distribution system operator who has to make sure everything works together. So this is how it is. Transactions on the left-hand side, and on the right-hand side is your microgrid. Why do I say microgrid? Because today in the US and no other country, the power company or the power regulation doesn't allow homeowner to sell power to the grid, doesn't allow that. You can, it allows to the grid, but not to your neighbor. That's the difference. If you have microgrid, inside the microgrid, you can transact between homes. Power company doesn't need to know that. This is the new thing we are focusing on. The issue I talked about here, this is happening inside a microgrid, not with the power company directly. So that's what this picture is talking about, microgrid-based homes. So for that to happen, we need what I call transactive controllers. They will look at the demand, look at the platform where the offer to sell is there, look at the platform where the buyers are giving their demand at the price they want to pay, and all those things have to work simultaneously. Example of what I call a building automation platform, which is where I talked about the wise building just now. The wise building is a building level platform which talks about the heating, cooling load, lighting load, plug load, sensors, rooftop solar, storage, and occupant comfort, meaning temperature setting. All of that information goes in, and then this building says, I want to buy power. I'm telling you, how do you decide how much you want to buy for the next hour is done by calculating all these loads and supplies. Then goes to the internet where the bidding happens. DSO make this thing work. So almost finishing. So if you look at a home today, this home has, example here, if you look at the top part, thermostat, dishwasher, refrigerator, water heater, it has rooftop solar, air conditioner, fuel cell, battery storage, and then power supply. Buying power from the utility, this is the red line, and managing this power, making sure all those devices, heating or cooling, dishwasher, refrigerator, they're met. Sometimes the price of electricity is very, very high. Even in the US, you got time of use pricing. Then you may decide to use your battery for some of the power to be consumed in the home, not buy from the power company. Or you change the thermostat setting for your air conditioner, reduce your load, or do not wash your dishes, or do not heat your water. Those activities are done by this thing called, I just showed you, this wise building platform that is being done today. So this is, again, an objective. We want to make it happen. So I'm done with the technical part, but I am an IEEE member. I am a faculty member, and I'm, like most of you or many of you, are suffering from or dealing with COVID-19. So what can IEEE do in this situation? We all know COVID-19 is a fast-moving thing, uncertain and complex. We all know that. But we know that we will also get out of this someday. So what I'm saying as a colleague, as another IEEE member with IEEE, we have to be ready for this. Talk about UAV, talk about solar energy, talk about energy internet. We know all these things. So how do we make sure that we go back to the new normal by cooperation, collaboration, and community spirit? For that to happen, IEEE has to be broader based so that the work we do becomes relevant to many people, many parts of the world. People meaning students, faculty, power company engineer, government lab people. All of that has to work for us to make a difference. For that to happen, we need more participation from volunteers globally in IEEE governance. And I believe a bigger IEEE, not bigger in numbers, bigger in contributions, will make us more relevant so that we are more useful to society. At the end of the day, we can talk about all the load flow, UV, all this stuff, but unless your children, my children, our students don't benefit from it, then there's not much value. So I'm finishing up. This is my last slide. As Puneet said, I'm running for IEEE president this year, but I'm going to spend too much time here. I just want to point out to you this website, www.sraman.org. And you have some questions. I give my email address as well. You go to the website, the slide I just presented is there already. You look at it, and if you have questions, let me know. So I think I have maintained my time, Puneet, and I am going to stop here and take questions or comments.
Yeah, thank you, Professor Saifur Rahman. So you have really finished well ahead of time. So we are having still 3 minutes. So I will take 1 or 2 questions which you can answer. And remaining questions, I request all of you, Professor Saifur Rahman has given his mail ID. You can reach out to him, immediately reply. That much I know. Is hydrogen fuel cell can replace battery or is visible for future of electricity generation? So that is the question.
Hydrogen fuel cell is a storage device in some sense because we store hydrogen and we use the hydrogen to make electricity when we need it. In that sense, they are similar. However, hydrogen fuel cell is not very widely available because it's expensive. And if you look at the PEM fuel cell, which operates at room temperature, is fine. Other fuel cells are very, very high temperature device. The answer is yes. Conceptually, they can replace each other. But practically today, I would focus more on the battery, which is widely available, than the fuel cell. But as it showed in my picture in the last couple of slides back, that's something we are considering as a storage device. Thank you.
Yeah, another question is there, how power distributed across ocean in energy internet?
Yeah, that's a good question. You know, there is a group that working on called Global Energy Interconnection, which is happening globally right now.
Yeah.
And they've talked about putting literally undersea cables from Russia to the Bering Sea into Alaska and to Canada and the US. That's the long term, but today there are undersea cable projects between part of China and Japan. Between China, island 100 kilometers out, they have undersea cable. They put the power back to the island. On the other side, if you go to Indonesia, there's undersea cables going forward. Malaysia, from Kalimantan to Malaysia Peninsula, talking about undersea cable because there's huge capacity in Kalimantan, not much load. Things are happening. So I would suggest you keep track of global energy interconnection discussions, and you'll see a lot of interesting ideas. I have another lecture on that topic, but not to.
Yeah, so I will take last question. Question is, what standards will have to be implemented between countries for energy internet?
Very, very good question. When I talk to people in India, China, Japan, Korea, Africa, this question comes out. If we are a buying country X buying country, because they don't want to spend money building expensive plants, they buy. What is the guarantee that the selling country would not shut down the power unilaterally? Very good question. I've talked about that significantly. The International Energy Agency has the same concern. They are doing some studies today as we speak, how to make sure the selling country cannot unilaterally turn the power off for a buying country. Then the buying country feels more confident to buy, otherwise they will try to build internal to their borders. Good question.
Yeah, thank you, Professor Saifur Rahman. Because of paucity of time, it is difficult for me to take more questions. But however, I request all the participants to directly write to Professor Saifur Rahman at s.rahman@ieee.org. He will be generous enough to answer your questions. And thank you very much for providing a very, very wonderful idea of energy internet in this Connect as a keynote speaker. On behalf of IEEE Bangalore Section and on my own behalf, I would like to thank you. Thank you very much. In addition to the panelists of today's keynote, Dr. Ashutosh Datta, Professor Kamesh, and I can see Professor Levant Sevgi has already left, but all of you, thank you very much. But please stay with us. I request all the participants also, because we are going to have a virtual cultural night of Connect. So if you like to join us, please do remain with us, and we are going to provide you a wonderful Indian culture extravaganza. So you will be more than happy to see that. Before going to the cultural portion, I would like to request Chengappa, because ANSYS is our platinum sponsor and they wanted to have some kind of survey with all the participants. So Chengappa, can you just shoot out those questions of survey, and I request all the participants to please fill those forms, because even this pandemic time, ANSYS has supported us wholeheartedly. So it is our duty to respond back. Thank you very much.
Thank you.
So I think Chengappa has already shared the questions. Yeah, please go back. Please go ahead, sir.
No, thank you very much for giving the opportunity. It was really nice. I enjoy all the talks. Thanks for organizing such a wonderful event, and looking forward to the cultural. So,
thank you. Yeah, Professor Saifur, you want to give some concluding remarks?
Unmute myself. So thank you very much, Puneet, and your team to do this. And I hope the audience has had many students, and they will listen to this and expand their vision that they can do many, many new different things. I just planted a seed in your mind that your imagination is boundless. And again, as an IEEE member, I'm very concerned about us IEEE maybe not playing our full potential to be relevant to the society, and not our society, society at large, like the people in Bangalore City, for example. So I hope our students can get that vision in their mind and be relevant to the community they are coming from. Thank you, Puneet.
Thank you. Professor Kamesh, would you like to give some concluding remarks?
Yeah. First of all, I think I listened to all the presentations. They were very informative and very valuable, especially for the students. And it's great to be here and be one among the and be on the panel actually. And thanks for the invitation, Puneet. It was wonderfully done. Thank you.
Yeah, thank you. So now I will hand over host right to Ashwini, who has she has curated this cultural program wonderfully. I think we wanted to have 1 hour of cultural event, but somehow she got so many entries. So we are going to have more than 90 minutes of cultural program, that too in a virtual event like this. So let us see how it goes. So definitely we are trying first time. So I request all the participants to be patient, because in Karnataka today there are heavy rains are going in almost all part of the Karnataka, and our students, members, they are mostly from remote places because we wanted to give them opportunity. So there may be some connectivity issues. We have tried to have a backup video already with us in case we are not going to play those performances in live. We will be playing the recorded videos. So Ashwini, over to you. You can take ahead from here. I'm giving you the host right. So you are a host now. You can make all the panelists of participants and then start the program.
Hello, sir. Many thanks. It's wonderful to listen to such elite presenters and talks. It's been a hectic day. So, as Puneet sir told, kindly be patient. Well, I'd like to actually take some time to walk you through what's there in store for today. Yeah. So what we have with us over here is a wide array of programs. I've been very fortunate to actually, get this opportunity because when the lockdown and the pandemic started, there was a lot of anxiety that people had. So I'm really glad that during the time that we got to read and reflect on the words of our great leaders, uh, there was a lot of direction and hope that we received. And working on that in the past 2-3 months, we got to interact with a lot of talent in the IEEE section, be it through webinars or many other virtual events. And through this media, we were actually able to get a lot of people who are interested in this particular event. And there have been a lot of people who helped. So I request you to kindly be patient for a while. Okay.
Ashwini, you can hear us?
Yes, sir. I'm just trying to find one person, and that's it. Just give me a minute.
You just click to the attendees and search.
Yes. Yes, right. Okay. Here we have. Okay. So here we have the agenda for today. Before I walk you through what we have at store, we have quite a lot of programs with us, and we will start with an invocation by Ms. Anagha and Sushmita of KSIT Bangalore Student Branch, and then followed by some young students from Sadhana School of Music, who will be playing us some wonderful composition from the great masters, followed by a popular rendition of some Hindi songs by Dr. Shraddha Mishra, followed by some inspirational songs rendered by Mr. Rahul Kakadam from the student branch of CEC, followed by the Women in Engineering chair of NITK student branch, giving a rendition to the very famous song by Bipen Hazarika, O Ganga. This will be followed by a medley, an experiment by some students from Bangalore subsection, followed by a Veena recital by Ms. Sri Lakshmi, and we will try to have another medley in the Indian classical fusion by our Bangalore subsection students Sridhar and an NIE student branch student Samvatsara Hegde, followed by a folk rendition, which will also be on the virtual platform, followed by a flute recital and a very unique program, which I'll ask Ms. Sadhana to actually come forward and tell us, because she was the one who inspired us more about inclusion. So we are trying an experiment here where we will try to actually make a sign language interpretation of a very popular Rabindra Sangeet by Ekla Chalore. So I request Sadhana madam to kindly speak a few words regarding inclusion.
Yeah, thank you. Thank you, Ashwini. Good evening to all. A warm welcome to the cultural program of Connect 2020. Any cultural program is incomplete without singing, which involves a lot of sound and music. However, there's a section of society who are differently abled. In order to have an inclusive society, we will be presenting to you a program which is a song in sign language. Looking forward to Shiny singing Ekla Chalo in sign language. Best of luck to Shiny and all the participants. In the end, let us all clap in sign language by raising both our arms and wiggling it. Over to you, Ashwini. Ashwini, back to you.
Yes, madam. Thank you so much. I hadn't realized that I had not muted myself. I now request Anagha and Sushmita to kindly render an invocation in Bharatanatyam.
Ashwini, remove the slide so that we can come to the full screen. Ashwini, please remove the slide so that they can come to the full screen. Yes.
Yes, Anita. Yes. Yes. Anagha?
Yes, ma'am.
Yes, can we start?
Yes, ma'am.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। ध्याय धीमहि गुणशरीराय गुणमण्डिताय गुणशानाय धीमहि गुणाय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भागवताय चतुराय
Many thanks. I now request Ms. Anaga to kindly give the next rendition. It is very interesting to note that we are rich. I request all panelists to kindly mute themselves. I now request Ms. Anaga to kindly render the next rendition. We are very fortunate enough to have rich culture of Dasa Sampradaya. So she is going to give a rendition on Devaranama, composed in Raga Sindhi Bhairavi by Purandara Dasaru. Anaga has been a student of Vidwan Srimati Deepa Bhatt since 8 years. She is presenting a Kanakadasa Kriti that expresses the gratitude towards Lord for being present everywhere and holding the hands of his devotees. So over to you, Anaga.
Thank you.
Thank you, Ms. Anaga. We now have Sushmita with the next rendition. We are also fortunate to be blessed with a lot of ladies. She is going to perform the greatness of Devi Kamakshi, who embodies the autonomy of nature, one who shall never be conquered, and she holds the sugarcane bowl and the arrow made of flowers and parrots. Over to you, Sushmita.
Kanjadalayatakshi Kamakshi Kanjadalayatakshi Kamakshi Kanjadalayatakshi Kamakshi Kanjadalayatakshi Kamakshi, Dagaya Kashi, Kamakshi, Dagaya Kashi, Kamakshi, Dagaya Kashi, Kamakshi, Kamala Manohari, Kamala Manohari, Tripura-Sundari, Dagaya Kashi, Kamakshi, Kamala Manohari, Tripura-Sundari, Kamakshi.
Many thanks. I now request the students of Sadhana School of Music to kindly be ready. Well, thank you, Sushmita. It was very nice. We now have Ms. Kirtana, Arav, and Rushil from Sadhana School of Music. From Sadhana School of Music, which started in 1991 by the legendary playback singer Ms. Manjula Gururaj. The school has been teaching music and training people of all ages and has inspired hundreds of them to become full-time professional musicians. Her son Sagar Gururaj, a Kannada film music director and singer, teaches keyboard and piano and trains students for the prestigious London College of Music graded examinations. Today we have his students performing for a duration of 15 minutes. At first, we will be having Ms. Kirtana, who shall be playing Henry's Little Waltz, followed by You Are the Hero and Oh My Love is Like a Red, Red Rose, and finally Dance With Me. After her, we will be having Mr. Arav. So requesting Arav and Kirtana to be kindly ready.
Thank you, ma'am. Ma'am, can you hear me?
Yes, honey, just a minute, please.
Okay.
Wait until I pin your yes. Okay.
Any problem,
Yes,
Ashwini?
you can start. Yes, can you start, please? I want to pin her view. Oh, yes. Yes, can you please start? Requesting everybody to kindly mute themselves and Kirtana start.
Okay, ma'am. Thank you, ma'am. Hello, everyone. Hello, everyone. My name is Kirtana. I am studying 4th standard. I am learning keyboard at Sadhana Music School, taught by Sagar Gururat sir. Now I am going to play Henry's Little Box, composed by Andy Smith. Now I am going to play You're the Hero, composed by Penny Widden. Now I am going to play Oh My Love is Like a Red Red Rose, composed by Andrew McBurney. Now I am going to play Dance with Me composed by Janet Dowsett. Thank you, Ashwini ma'am and Sagar sir, for giving me this opportunity. Thank you. Ashwini ma'am? Back to you.
Yes, many thanks, Kirtana. Now we'll be having Arav on keyboard, and over to you.
My name is Arav, and I learn keyboard at Sadhana Music School. My teacher is Sagar Gururaj, and I will be playing four release composed by Ludwig van Beethoven.
Madam, you can start. Yes.
Yes. Hello, everyone. एक अजनबी हसीना से यूं मुलाकात हो गई, फिर क्या हुआ ये न पूछो, कुछ ऐसी बात हो गई। एक अजनबी हसीना से यूं मुलाकात हो गई, फिर क्या हुआ ये न पूछो, कुछ ऐसी बात हो गई। वो अचानक आ गई यूं नजर के सामने, जैसे निकल आया घटा से चांद। वो अचानक आ गई यूं नजर के सामने, जैसे निकल आया घटा से चांद। चेहरे पे जुल्फे बिखरी हुई थी, दिल में रात हो गई। एक अजनबी हसीना से यूं मुलाकात हो गई, फिर क्या हुआ कि न पूछो, कुछ ऐसी बात हो गई। जाने मन जाने जिगर होता मैं शायर अगर, ये कहता गजल तेरी अदाओं पर। मैंने ये कहा तो मुझसे खफा वो जाने हया हो गई। एक अजनबी हसीना से यूं मुलाकात हो गई, फिर क्या हुआ ये ना पूछो, कुछ ऐसी बात हो गई। Thank you everyone. Thank you for listening. Hello.
We are not ready to let go of you yet. So I think you have another song in your kitty for us. Do you?
Yes. Yes, ma'am.
Yes. So let's wait a while you get yourself ready.
Yeah. Ma'am, I'm ready. Hello.
Yeah, please go ahead with your performance.
Yes, madam, do go ahead.
Am I audible?
Yes, you are.
सागर किनारे दिल ये पुकारे, तू जो नहीं तो मेरा कोई नहीं है हो। सागर किनारे दिल ये पुकारे, तू जो नहीं तो मेरा कोई जागे नजारे जागी हवाएं जागे नजारे जागी हवाएं जब प्यार जागा जागी फिजाएं हो पल भर तो दिल की दुनिया सोई नहीं है सागर किनारे दिल ये पुकारे तू जो नहीं तो मेरा कोई नहीं है वो सागर किनारे दिल ये पुकारे तू जो नहीं तो मेरा कोई नहीं है thank you everyone for listening.
Hello, that was a wonderful performance. Can you just please bear with me until I have our next presenter? Who is unable to join us? was Rahul Kakadan from Bangalore Subsection, Canara Engineering College. The two compositions were very emotional and very dear to one's heart. So we now have Pragna Hebar, who's going to give a rendition on Bhupen Hazarika's O Ganga. Many a people have been rendered speechless by Bhupen Das' song O Ganga Behti Ho Kyun. So give me a minute when we have Pragna ready. So Pragna, I need you to tell me when you're ready. Pragna? Yes, I don't get a video feed from you. No, I don't. Yes. Yes, Pragna. On the cue of 3, you start. 1, 2. We lost you there? Yes. Can you see me now? Music, please. Well, many thanks. That was a very beautiful rendition indeed. We now have Ms. Sri Lakshmi. Ms. Sri Lakshmi on Avina recital. So, Ms. Sri Lakshmi, over to you. Many thanks for the wonderful presentation. I'm sorry, recital. So we now have with us a duo from Sagar, Mr. Sridhar and Samvatsara Hegde. So over to them, Sridhar and Samvatsara. Just a minute. Yes. Yes, you are. Wait a while. Yes.
point of present. I'm Sridhar from engineering in Canara Engineering College, and he is Samvatsara, my friend. He is on tabla, and he is from NIE College of Engineering, Mysuru. I will present the raga Yaman. Am I audible?
Yes, Sridhar, you are. Please start.
Madani mani marega rega marega rega madani mani madani sa ni da pa marega rega pa marega Yeri yali ya bina agamadani sa yeri yali ya bina yeri yali ya bina yeri yali ya bina yeri yali ya bina kalana parat mone bari palaki kalana parat mone bari palaki ye ya bina sakiye ya bina saki Ramadani Ramadani Manila Ramadani Ra Jabane piya to tan basaki no Jabane piya to tan basaki no Jabane piya tan basaki no Jabane piya to Jabate piyaso, jabate piyaso, tan basakino, jabate piyaso, tan basakino, jabate piyaso, tan basakino, ratiya kadita mohnai.
Thank you.
Wow, that was very refreshing. Many thanks. It's as if we've had a power nap and all ready to go to something really new and adventurous. Many thanks to both Samvatsara and Sridhar. So we have the next person to present a flute tune, and I'll leave you to tell me what it's going to be next. So we have a very enterprising young man with us here. Let me just try to bring him online. Okay. So Suman Shanai has been one of my favorites. He is an entrepreneur, a fresh engineer, and with Stelna Designs, he's got a lot of things in his kitty in his pipeline. So he's going to play a flute. Thank you. Please, on the count of 3, can we start? Yes, you are. Yes, on the count of 3, 1, 2, and over to you.
Namaste. I'm going to present a musical cycle in Rag Des. Okay.
Many thanks, Suman. So kindly bear with me. That was a wonderful presentation. Request all participants to kindly bear with me for just a few seconds until I'm able to share something that's very close to my heart. Requesting all of you to kindly have a look at this until I have my dearest people ready for a special event. Okay. So we have here with us Shiny and Pallavi going to give a rendition to the popular song by Rabindranath Tagore, Tobe Ekla Chalo Re. So I'll just scroll through these slides such that you can just have an idea of the lyrics. While I have the floor ready for Shiny and Pallavi. Okay, so I hope all the viewers are able to see them one below the other, stacked. Chengappa, can you just let me know? Puneet sir? Okay, so good evening, ladies. I'm sorry, this is going to be the last piece that we have for all the attendees today. So I would like to first give an introduction to the idea behind having this event. My sincere thanks to Enable India for having made us able to identify Shiny, who shall be interpreting the song Ekla Chalo Re. A brief about Enable India: the strive to bring dignity to persons with disability through economic independence and to build a world where everyone is a change maker. They have an impressive track record in placement of more than 20,000 plus persons with disability with livelihood in 300 plus job roles. Our interpreter for today, Shiny, is a native of Shillong with Masters in Industrial Psychology. She works for corporate social responsibility at an MNC and wishes to be identified as a volunteer for inclusion. Anything for inclusion is her motto. Glad to have Miss Pallavi Pai from Canara Engineering College lend her voice to the very moving composition by Gurudev Rabindranath Tagore. So without much ado, over to the duo Pallavi and Shiny at the count of 3. 1, 2, and over to you, beautiful ladies. You may start.
Namaste. I hope I'm audible.
Yes, honey.
Yeah. যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে, যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে, একলা চলো একলা চলো একলা চলো একলা চলো রে, যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে যদি তোর ডাক শুনে কেউ না আসে যদি কেউ কথা না কয় ওরে ওরে ও ভাগা কেউ কথা না কয় যদি সবাই তাকে মুখ ফিরায় সবাই করে ভয় যদি সবাই তাকে মুখ ফিরায় সবাই করে ভয় তবে পরাণ খুলে ও তুই মুখ ফুটে তোর মনের কথা একলা বলো রে যদি তোর ডাক শুনে কেউ না আসে তবে একলা চলো রে যদি তোর ডাক শুনে কেউ না আসে দেনা 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 তানা রে যদি শোভায় ফিরে যায় ওরে ওরে ও ভাগা শোভায় ফিরে যায় যদি গহনপতি যাবার কালে কেউ ফিরে না চায় যদি গহনপতি যাবার কালে কেউ ফিরে না চায় তবে পদের কাঠা তবে পদের কাঠা তুই রক্ত মাখা চরণ তোলে একলা ডোলরে যদি তোর ডাক শুনে কেউ না আসে তবে একলা চলো রে যদি তোর ডাক শুনে কেউ না আসে যদি আলো না ধরে ওরে ওরে ও ভাগা আলো না ধরে যদি ঝড় বদলে আধার রাতে দুয়ার দেয় ঘরে যদি ঝড় বদলে আধার রাতে দুয়ার দেয় ঘরে তবে বজরা নলে আপন বুকের পাঁজর জ্বালিয়ে নিয়ে একলা জ্বলরে যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে একলা চলো একলা চলো একলা চলো একলা চলো রে একলা চলো একলা চলো একলা চলো একলা চলো রে যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে যদি তোর ডাক শুনি কেউ না আসে তবে একলা চলো রে Thank you.
Well, many thanks. I request all of you to kindly give a wiggle and raise your hands in a silent language as applauding the audience. Many thanks. You can raise your hands and wriggle. Many thanks. We were not able to accommodate a few of the presenters, so I will be scrolling. I'll be scrolling a particular folk song, the words that will be narrating, but that's it from now for us for today. So hope that all of you will stay safe and healthy. Over to you, Puneet sir. Puneet sir? Wow.
Yeah, actually, thank you very much. Thank you very much for curating this very, very nice cultural evening. I think we tried our best for the first time doing a cultural event in virtual mode, and we have done quite well. Friends, with this, we will be ending the program, and tomorrow morning, 8:30 a.m. again, we will be meeting with morning keynotes. Thank you. Thank you very much.
requesting you not to sign off yet and just keep it on audio only mode and listen to what Sharadi has in store for us in Sojugada Soji Malige. Thank you, Puneet sir. Thank you, IEEE Bangalore Section, and for all the dignitaries who were here today and made our day interesting. So, on a nice note to end your day, here is it, Sharadi from SSIT Tumkur singing Sojugada Soji Malige. Well, I really do not want to be called biased, or so I want to actually let all of you enjoy what our participant Sam has in store for us. So Sam is a person from is a student from St. Joseph's Engineering, and he and his friends from Bangalore subsection have this lovely, wonderful video that they have put together in lockdown. So please make time for this as well if you are online.